Today, inshallah, I will start with this new chapter, chapter 5 on directional relays. In the introduction chapter, I have already talked about why do we need directional relays. I'll just go over it, okay, and sort of definition, their types, how they are working, and how do we set them, okay, so that they work on one direction. In order for direction relay to function, the switch off my phone. For direction relay functions, this is the first definition. Direction relays, as per IEEE definition, is a relay that responds to a relative phase position of a current with respect to another current or a voltage reference. Now we need a reference based on which we decide if the direction of that current, is it in forward or backward, okay? And it is based on phase relationship between the current and the reference quantity. I'll show later what's the phase difference and we could have directional overcurrent relay. This is the 51 relay plus a directional unit, which makes them directional relay. We call it a code is 67. Okay. The directional ground over also is not only phase overcurrent relay, it could be also directional ground overcurrent relay. So these are overcurrent relays. Directional power relay, where it just measure the power and see if the power flow direction during normal operating conditions. Okay, how power, if the power reversed, then indicates there's an issue sometimes. Especially when we have a turbine, when in a generator, when you lose the turbine, the power in the synchronous generator will reverse. So it will take power instead of supplying active power. And in that situation, we want to trip the synchronous generators. And to detect that direction as reverse, we use a directional power relay. Okay. However, this acts to detect fault direction, while this acts to detect the power flow during normal balance conditions. Still when the power reverse in the synchronous generator, still it will be balanced, but it is only that the current has reverse or the power has reverse. Directional comparison, we have sometimes we compare the direction only without using the current. Okay, this is in transmission system. We compare, are these two relays at the end of the lines are seeing a fault in one direction, then okay, or they are in different directions. Okay. So what's the problem now? The problem, why do you need directional and non-directional relays? They would fail, okay. The coordination what we did before in the previous chapter would fail when the fault, flows in both directions. And especially when we have, ring or mesh systems, loop system, such as parallel lines, and systems with more than one in-feed point, or more than one source. In this case, we have more than one in-feed. For this case, although we have one in-feed, one source, but we have a loop system. Okay, so for these two situations, coordinating with non-directional relays would become tedious or something impossible. Okay, and now I just showed this before in the introduction chapter. I don't want to go over it. So if we have a fault here, okay, in order to protect this line, I need to have two relays is when you have a ring system, you have to have two direction relays at the two end of the line. Okay, because as you can see, if the fault here, the current will come from this end. Now when a fault here, the current will flow this end, this direction, and if this will flow on that end, will flow in this direction. So the current flows here direction, this flows in this direction. Okay. Now when the fault current at other locations, so suppose it flows at here, okay, then the current flows here in this direction. Now this relay, the flow will be, the current will come here. Now this current will be in this direction, right? And that also will be in this direction, the current direction. And this will be also in this direction. And this will be in this direction. While in the previous case, the current flow in each of the relay, and this relay will be when it was fault at here, this will be in this direction, this will be in this direction, this current in this direction, while that current, when the current flow in this direction, this current is in this relay, and for this relay the current was when what is in this, it was in this direction. As you can see, the current will reverse, okay, across this.
دكتور ايش فائدة البسط اللي في النص بينهم؟
عفوا؟
ايش فائدة البسط اللي بالنص بينهم؟ هذه 3 و4 اللي صار فيه الفولت، ليش حاطينه
أيوة.
احنا بس؟ يعني ايش الفائدة اني اوصلها؟
هاي عبارة عن two substation. This is one substation. This is another substations. Okay, so they are different. They are far away from each other. So a bus is just a connection point between one transmission line and one feeder coming from, let's say, a supply substation. This could be a primary substation which convert a voltage from, let's say, 66 kV, and it converted to 11 kV, for example. So this is the main transformers here feeding this substations. Okay, so this is 11 kV all right. So this 11 kV, I want to distribute it to different block areas, or like this is block number 1, which have several houses here. There's block 2, several houses or roads here. So these two areas, not near to each other. So we have cable that connects to each of these areas. So this is like a loop now. Now this load 1 here is not close to load 2. Okay. And we need a cable that connects between this substation. This substation also will have probably, it's not shown here, but I would like to show in details. This load could be 11 kV, but could be also a transformer here that feeds several loads. Okay, and this is at 400 volt, for example, or 415 volt, which change the voltage from 11 to 150. So we summarize this as a feeder load, but maybe this cable goes to one consumer here, another consumer here, another consumer here. We don't go to that details. Okay, so we have also protective devices that acts for each house or each individual loads. We have also protective devices here, which I am showing. All right. So this is a portion of a complete system. Now, my point here, if a fault is here, the current only flows in one direction. Okay. if a current's here, the only current, if the fault is here, it's only current flows in this direction. Doesn't go in the other direction. And this 7, suppose this is the 7, only flows in this direction. Okay, because I have no source at this end that feeds back a current, and so there will be no possibility of even if I have a protective devices somewhere here. Okay, at the beginning of the feeder, like this is what normally we have, fuses, for example. The current only flows in one direction, while in these, I notice this is in same direction. These are reverse direction. This is reverse direction. I can show you if the fault is here. This also will have reverse because it has a current flow in this direction. This so will also reverse. So when you see a current that can reverse across a protective device, that opens the door for thinking of a directional relay. Okay. If the currents only flows in one direction in the relay always, then you don't need a directional relay. Okay. And this is the philosophy. Okay, or the basis based on what you decide whether you need a directional unit or not. This is one thing, one criteria. So in order to avoid, this, I would need a direction unit here, a directional unit here, a directional unit here, a directional unit here. Okay. Similarly, for this, because a fault here can have a current in this direction, this current will be in this direction. However, as you can see before I go to the next, and this 2 breakers, always the current in this direction, regardless of, because if the fault is here, okay, there'll be no current going from these loads goes back to, so there'll be no reversal of current across these 2 breakers, breaker 1 or breaker 6. So this can be non-directional. Okay, so this is non-directional. And these 2. However, all of these has to be directional relays. All right. For this example also, if I have same thing, I have 2 in feed, 2 sources that feeds these loads, and for a fault here, this current will be this direction, this current will be in this direction because current flows in this way. Also, this current will be in this direction, this current will be in this direction. However, when a fault is at F2, okay, the current also will reverse and will have an issue. When a fault at F2, this will be in this direction, this will be in this direction. So this will have 2 direction reversing. Okay, and similarly, this will have in this direction. So they will have a reverse, but this also will have only in this direction. Unless the fault is here. If the fault's here, then this current will become still, okay, in this direction, because it's coming from all of this way, goes here. So this also would reverse. Similarly, if a fault here, the current flows from it will be in this direction. So this would also have a current in this direction. So across this 2, 3, 4, and 5, the current will reverse, and thus we need to have a directional units here, directional relays, overcurrent relays. All right. So as a result, I have decided I have non-directional relays here. Yes.
دكتور بي واضحة، لكن A ما فهمت على أي أساس صار بين 3 و 4. البي فهمتها واضحة، لكن دكتور في الA ما فهمت
أيوة.
كيف حيصير الفولت between 4 و 3، البس اللي بالنص بينهم.
الصوت يتقطع. البي قصدك هاي فيجر بي؟
بي واضحة دكتور،
تقصد
فهمتها.
فيجر بي؟ اوكي.
أقصد إيه يا دكتور الفولت اللي في النص هذا كيف حيصير دايركشنال ولا لا؟
هذا الفولت اللي هني،
اللي
هذا
في إيه؟
هذه حين هذه
اللي في
ايه
إيه
صحيح؟
دكتور؟ إيه إيه هذا هو.
اوكي. الفولت هنا، الفولت بين 4 و3.
أيوه.
اوكي 4 و3، لو الفولت بين 4 و3. Just mute the speak mouse المايك. Anyhow, so if you fault between 4 و3, the current will flow in this direction, هاي red line, flow current also from the other side. So this is the direction of the current flow that pass through each breaker or each relay, right? It will flow this way, this way, this way, and it goes, right? So this is the direction of the current. And this is the direction of this current for now. But with the current here, the current will be, for this one, will be in this direction. When the current is when the fault is here. Okay. Now this current will have the same direction as the previous when the fault's here. Even if the fault's here, still the current will flow here. So this will not change the direction of current. While in this one, it will change now because the current flow here from that end, from the 6th side, but the current flow also from the one side breaker goes here, goes here, goes to until it reaches the fault point. So the current will becomes in this direction. Okay, when the fault is here, the current also will pass through here, coming this side. So in this case, this relay, when a fault's here, the current was in this direction. When a fault's here, the current becomes in this direction. So across this relay or this breaker, I will have a current directions that would reverse, okay, depending on the fault location. As a result, I need to have a directional unit here, a directional overcurrent relay that only acts in one direction. Okay. Is it okay now?
Yeah, I get it. Thank you.
Similarly, the same thing with here. This will have a current in one direction, and this direction when the fault is here, it will be in the other direction when the fault is here or here. So only these two that doesn't affected by the fault location.
Doctor.
Okay. Now.
If we have fault between generator and pulse at A, wouldn't the direction of 6 and 1 would be bidirectional?
If you have again أنا ما كنت أسمع بشكل واضح.
إذا عندنا fault between generator and bus A.
Okay.
Wouldn't that change the direction of the current?
اللي هو هذا.
Yes.
Won't change the fault لأن from this load we don't have any generation. Okay.
Okay.
I don't have any generation. These are radial system loads.
صح.
So those won't supply current backward. So when I have current here, only current goes from this direction. There will be no current reversing. So even if I have a breaker here, okay, I don't need this breaker to be directional because always current will be in this direction. There will be no current reverse from the other side, from the load side. Okay.
Yes, thank you, doctor.
Similarly, this one, it can be non-directional. Okay. So for direction only, we put one arrow as we showed here directly. Now we say this is non-directional, these two. This has to be directional, it has to be in this way. This has to be in this direction. Trips only when it sees a current in this direction. Okay. This is also this. This is same. So this has to be direction, the tripping direction, always facing each other. This should be non-directional. No need for at 1 and 6, no need in this case. Similarly, if I have a breaker here, okay, no need to be directional, so it could be non-directional. Okay. Now, how do we coordinate now for fault here? The current will be in this direction. So this will see a fault in this direction. This will see a fault in this direction. And the current also will pass in the other direction. So this will see a fault in this direction. Will see a fault in this direction. This relay will see the fault because coming in this direction, it will see a fault in this direction. And that will see a fault in this direction. And because these two see a fault, their fault is same as the trip direction, so this will operate, and this is also will operate. This is the 2 and 5, they are seeing fault opposite to the trip current direction, so this will restrain, it won't operate, even if the current is very high, greater than setting. Similarly, also this one will not operate. It will not operate. Okay. So not operate. For the 2. However, this and 3 and 4 could operate. Now we have to set the timing such that 3 and 4 operate first, then these 1 and 2, 6 should be as a backup. So in our setting, we'll make this at a lower time, let's say 0.1 second, 0.1 second. Okay. No, I will not. I will show you later how do we set them. But suppose, okay, I'll show you later how do we set the timing. But at least these two will operate first, then last this will operate. So I'll clear this fault. Once this 2 breaker operate, now this line will be healthy, this line will be healthy. They feed each of these loads. I will not lose these loads. Okay. And this also could be non-directional. Why? Because current in these will not reverse, whether a fault is here or here, because there will be no current feeding from the load side. Let me show the pointer. So for this also, I don't need directional because only one direction, whether a fault is here and fault here, there will be no current flows in the other reverse direction. It's always fault in this direction. So I don't need direction, similarly for this one. Now, how do we set these such loop system? Okay, all what you need to do is you cut the loop into so that becomes like a radial. I'll cut the loop from, let's say, number 6. I will open this loop. So when you open it from this loop, it will looks like the current will flow only in one direction. Okay, right? If you open it from here, the current only has a path to flow up to here and stops. Okay. So in this case, what I'll do, in this case, once I open 6, I will coordinate the relays that see the faults in one direction. So I will coordinate 1, because now the current only flows in this one direction. In this case, once I open this, okay, for a fault here, it only flows in this direction. There will be no current flowing here. So this I will coordinate now. The ones that sees a force in the same, I will not take this into coordination, not this because they were restraints. So I will coordinate 1 with 3 with 5. I'll coordinate this relay 1, 3 with 5 because they see the faults in one direction. Once I open 6, okay, and I will coordinate them. So they become like a radial system. So this is the end where sits end. So I'll coordinate them as we did in the previous chapter. I will start with 5. I'll make it at my minimum time. So suppose I coordination by time. So I'll set 5 at minimum time. We'll say 0.1 second. Then I'll go this. I'll add coordination time interval. So I'll add this, let's say 0.3 second to it. So it's 0.4 second for 5. And I'll add another 0.3 seconds here will be 0.7. So there'll be 0.1, 0.5, 0.4 seconds, and this is 0.7 seconds. So this is coordination by time, by using a definite time over current relays, okay? So if the faults here, which relays of the fault at F1 means this relay at, before I get to this fault at F1. Now the second part, how do you set the remaining relay? You open now relay at, you open now the breaker, this breaker now, you make it open. And once you open it, this only fault will flow only in this direction. Okay, and you can coordinate now 6 with 4 with 2.
دكتور
نعم.
اتوقع الشاشه معلقه لانه احنا لنا نص ساعه على شيء واحد والماوس واقف في النص وانت شرحت كثير اشياء مو شايفين شيء.
مو واضح الحين عندكم او الحين الصوره اي صوره عندكم؟
الشاشه دكتور الحين جاتنا الصوره ثانيه بس لك 10 دقائق كان في الصوره الاولى وما في شيء تغير يعني انت تتكلم والصوره هذيك واقفه. هذا كله دكتور الحين طلع مره واحده.
اوكي الحين حاليا لو كان عندي راديال سيستم او خاص لي رينج سيستم شلون نسوي كوردينيشن للتايم؟ اوكي الفكره اني اي اوبن افتح اللوب هاي هذا رينج سيستم صح؟ فافتح اللوب at one part I open it at let's say number 6 and once I open it at number 6 the loop becomes like a radial. Okay, it will be open up to here. So once you open it, the current will be flows only in one direction as it's shown by the red path. When I put somewhere here. Now in this case, then you just coordinate the relays that sees a fault in the same direction. So I'll coordinate 3 with 5 with 1. And I will select the last one as my minimum time. Okay, as we did in the previous chapter, I can coordinate now 5, 3, and 1 using grading by time or grading by current or grading by time and current. So if you use grading by time using definite time over current relay, I will set the last one at my minimum time, 0.1 seconds. Then it's 0.4 seconds where I use 0.3 as a coordination time interval. And add also 0.3 seconds. I'll get 0.7 seconds. So I'm done from setting these relays. Now for a fault, then to set the remaining relays, okay, you open now at the at breaker 1, so the current will be as the blue path, okay, when a fault somewhere here. And in that case, you just need to coordinate between now 6 and 4 and 2, and so the circuit will looks like this as a radial system. So this is where number 1 is located. And so these are, because this is non-directional, this was a directional, this is a directional. So I'll set this as also 0.1 second, the last one in the loop at 0.1 second. So sorry, when I open this, the last one will be number 2, okay, which is this one. I'll set it at my minimum time. Then I'll add coordination time, let's say 0.4 second with 0.3 second difference. And this is also add 0.3 second, I'll get 0.57 seconds. Now, we are done. This is what we do here. It's like a radial system. We'll do the same procedure in setting these relays using the procedure covered in chapter number 4, okay? And overcurrent relays of radial systems. Now, once we sit here, now we can check would this work or not. I will just delete those arrows again. Now, if the fault is here at this location, now which relays that will see this fault? Number 3 will see it, and number 4 will see it. Number 5 will not. Why? Because current will flow in this direction and it's opposite to the trip direction. Number 2 will not see it, this, because current flow in this direction and it's reverse to the trip direction. Also 1 will see it because non-directional, and also 6 will see it. Now, how long will 4 will take? It will take 0.4 seconds to trap. And this also will take 0.4 seconds to trap. So after 1 second from the presence of this force, these 2 breakers will open, while these 2 will not open because it will take 0.7 seconds. So before 0.7 second reached, these 2 breakers will open. Once 3 and 4 open, the current will stop flowing from 6 and 1. So these 2 breakers will reset again to their normal operating condition as there is no fault because 0.7 seconds not reached. As a result, I have achieved selectivity by clearing only the faulty line. Now, if the fault is changed to another location, I will change this color to red. نعم.
دكتور الحين لو كان الفولت بين 3 و 4 مو 2 بيشتغل بعد رغم انه هو 0.1 second.
ما بيشتغل لان الدايركشن fault is this direction, right? And the current will flow like this. First flow direction, the current direction is here, opposite to the trip direction. Although there is a flow that but won't trip, because it's not in the same tripping direction.
اوكي ايش كان؟
هذا لما يكون 0.1 second لو كان non direction. It will. يعني شوف المشكلة هني لو كان هاي non-direction كان هذا be trips before this. So I will also trip this line. I will lose selectivity. But changing it to directional, I'll be able to avoid this situation. I mean, it becomes a selective. Okay. I have correct operation to clear these faults. Now let's change the fault location. If the fault location is I will change this, I will raise it. I will suppose now fault location is here. Okay. How's the current flows? Flows this way, fault, and fault will come here goes to that. Okay. So in this
كان في
case,
ديلاي قوي ما نشوف بالضبط. يعني أنت تقول جاء من هنا وراح من هنا وعندنا الشاشة ما فيها شيء، بعدين يطلع مرة واحدة أسهم أزرق وأحمر
الظاهر في مشكلة عندي بالنت. اوكي.
يعني
النت
دكتور
ضعيف.
نسمعك تقول من هنا ومن هنا بس ما نشوف ولا شيء، بعدين مرة واحدة يظهر فجأة أزرق وأحمر وأسهم
اوكي.
الحين تغيرت.
Okay. I will try to be slow. Okay. To cope with the slow in the internet.
أوكي يعطيك العافية.
اوكي. واضح ان لما الفولتس كان في هالمنطقة، في المنطقة حين الزرقاء بين 4 و 3، هاي جاوبت عليه. الحين غيرت موقع الفولت الى هنا المنطقة هاي اللي صاير بين بريكر 6 وبريكر 5.
عندنا الماوس من أول ما قلت منطقة هو تحت معلق على القلم، يختار قلم أحمر وأزرق، ما طلع فوق أصلا.
اوكي، انا جاوبت على سؤالك كان لما انت قلت لي ليش التو.
أنا فاهم دكتور، بس أنا أنت
أوكي.
جاوبت بالصوت. الماوس تحت عند القلم ما طلع أصلا.
اوكي.
الماوس إلى الآن يختار قلم أحمر.
اوكي. اوكي، ليش ما في حال وجود الفولت بين الفور والفايف، بين الفور والثري، الفولت موقع بين الفور والثري في هالمنطقة. اوكي، ليش البريكر 2 will not operate؟ قلت لأن الكرنت في حالة وجود الفولت هنا فبيكون الكرنت في الاتجاه هاي. اوكي، بيتحرك في هالاتجاه إلى ما وصل الفولت. بالتالي الكرنت اللي بمر ثرو بريكر 2 بيكون في هالاتجاه، وهو معاكس لاتجاه التريبنج مال
دكتور
2.
ما نشوف، بس نسمعك تقول هالاتجاه ما نشوف.
اوكي. I will wait little bit. حاليا تشوفون الماوس يتحرك. تشوف حاليا موقع
الحين طلع دكتور الكلام اللي قلته، الحين طلع.
اوكي. طبعا لو الحين الفولت في هالموقع، اوكي، الكرنت اتجاهه هاي، بالتالي الكرنت في التو بيكون في هالاتجاه اللي عكس اتجاه التريبنج. وبالتالي الريلي at 2 although there is a fault current but it will not operate because of the direction of current. اوكي. واضح الحين إجابة على السؤال ليش لا 2 ما بيشتغل في حال وجود فولت بين 4. اوكي.
بس
الحين
ما
لو
نشوف
تغير موقع
السهم وهو
الفولت،
يتحرك، نشوف صورة نهائية.
اوكي، الحين لو الفولت غيرناه الى المنطقة هاي بين 5 و 6. alright. فوش شلون بيكون موقع اتجاه الكرنت؟ بيكون في هالاتجاه، او بيكون من الاتجاه الثاني، بيكون من بريكر 1 to breaker 2 to breaker 3 to breaker 4 to breaker 5 and reach the fault point. إذا في هالحالة بيكون بريكر اللي بيصير لهم تريب هم I'll change the color. اللي بيصير لهم detection هو 6 will see because this is one direction but it will wait 0.7 seconds. Number 5 also will see a fault because the fault current in this direction and the tripped current in the same direction. So this will trip in 0.1 second. So this breaker will open first, or breaker number 1. This is, it will open, trip. Okay. So once breaker 5 trips, there will be no current flows. Although breaker number 3 also sees the faults in the same trip direction, okay? But it will take 0.4 seconds to trip. But before 0.4 second comes or reached 0.1 second, breaker 1 has already tripped. So there'll be no flow of current coming from 1 to the fault points because of opening breaker 5. And now breaker number 6 is the only one that will keep feeding now the faults when it is at this point. So now once 0.7 reach, then 6 will also open.
دكتور في
نعم.
الموضوع الحين انت تقول ان بوينت 1 بيصير اسرع من بوينت 4 سكند، فعلى حاله اللي بين 3 و 4 الحين لو كان الفوت بين 3 و 4 مو مفترض بوس اللي عند ريلي 2 يكون اسرع من ريلي 4؟
ريلي 2 ليش اسرع؟
لان بوينت 1 سكند
ايه
والريلي 4.4
ريلي 4.4 اوكي ريلي 5
فولت يعني جاي من 6 و4 و2 كذي رايح.
اوكي الكرنت رايح في هالاتجاه. وين موقع الفولت؟
بين 3 و4
بين 3 و 4 اللي في هالمنطقة. اوكي
اي
والمفروض شنو يكون؟ شنو كان احتجاجك على شنو؟
على 2 ليش مو قاعد يعني مفترض 2 اسرع من 4 ليش 2 ما اشتغل؟
لأن قلنا هذا يشتغل لما يكون بس يشوف الفوت في هالاتجاه، لأن هاي 2 directional. على الرغم موجود في فولت كرنت يمر فيه والتايم 0.1 seconds، بس ما بيصير له ترب لأن الدايركشنال يونت doesn't see the fault in the trip direction. Okay, the fault is in this direction, fault current that goes to this fault, and the trip direction in the opposite. Okay, يعني we set a relay at 2-1. I will show you now how do we set the relay that sees a fault trips only in one direction. Okay, بس الفكرة هنا I just showing to you all of this time is just trying to show you this direction relay doesn't trip, okay, in both directions, only when it sees a force in the set direction. We set the relay to trip only when it sees a force in one direction. Now the question, how do we do this, okay, in the relay? All right, يعني مو بس ان الكرنت يعني في الدايركشنال ريلي في 3 شروط لازم تتحقق علشان الريلي يشتغل. اولا تشوف كرنت اعلى من البيك اب سيتنج، اوكي. الشرط الثاني ان الدايركشن يكون في اتجاه التريب دايركشن اللي احنا حددناه، اوكي. الشرط الثالث ان الوقت استغرق الوقت الكافي لان يصير له تريب اللي هي التايم سيتنج. اذا هاي الثلاث شروط تحققت بعدين يصير له تريب. الشرط الدايركشن ما كان موجود في النون دايركشنال. اوكي واضح؟
اي واضح.
اوكي خلينا نروح شلون نسوي الحين how direction relay is constructed and how do we set it. Now directional relay it's like a normal overcurrent relay. okay. لكن موجود معاه بالإضافة overcurrent relay unit عندنا directional unit، يعني عبارة عن two functions are added to construct one relay. So one directional relay plus an overcurrent relay. So this becomes a directional overcurrent relay. So how do we set the directional relay? Now, it used to be a separate, like a separate, another relay attached with the overcurrent relay. Nowadays, it's just a function in numerical relay. It's such an equation. Okay, so I might refer to the direction that I'll call directional unit or directional function or directional element. Okay, or stage of directional relay. So how do we set the directional units so that it will control the operation of the time over current relay, or whether it's so that how do you set it? We need something called a polarizing signal, a reference signal, based on which I decide the direction of the current. So this reference or polarizing voltage signal, is normally as a voltage, because voltage is not affected too much with the presence of photon as compared to the current. More stable signal, okay? And but we can use also a current as a reference signal. So we have two ways to control the directional relay controls the trip actions. One we call it control by supervision or by control. Now these two blocks, with D means this is the coil of the directional relay. When the current flows in it and sees the fault in the forward direction, it will close its contacts, the contacts. And the overcurrent relay, it has also a current coil. That same current flows in it. So when it operates, okay, when see this current higher than pickup, also it will close this contacts. Once these two contacts close, because they are series, I will have a trip signal generated. This is called by supervision. If the directional unit doesn't see the fault in the forward direction, this becomes open. So even if the overcurrent relay trips, it won't operate. And this, which is normally done, this is by supervision, which is adopted in most of the relays, that this won't operate from the first place, okay? If a directional unit doesn't see the fault in the forward direction, okay, then this becomes open. Once it becomes open, there will be no current flows in the overcurrent unit, and as a result won't operate, okay? And but once the direction unit operates, this will be closed, and once it's closed, okay, this overcurrent relay will see a current flow in it, and it will trip its contacts, which trips the circuit breakers. Okay, so how do we see this in electromechanical relays? Now, for overcurrent relays, I show this is the where the shaded ring is located. Now, instead of shaded ring, we use a here shaded coil. A coil that is purposed to split the fluxes and these two. So we have two fluxes that are displaced in phase, so that we have a torque initiated. Now, directional relay is the relay that will close these two coil circuits. If the directional unit sees the forward fault, this will close these two contacts. Once close these contacts, and so I'll have a current flows due to the induced EMF and these two windings. All right, and as a result, the disc will move. But when this direction is open, even if the current is too high, that the flux is high enough, but these two fluxes will be in phase, so will be no torque developed. Okay. Similar, this is on shaded pole type. In wattmetric type, it's the same concepts. Now we have two coil, one for the current coil, where this is from CT. This is CT goes here. So this is a current goes from the CT, and this is also CT is here. Right? So from that CT, I have a current here. Now I have also another coil, and which is connected in series with the directional relay. If this directional relay sees a fault forward, it will close this contact, which makes the second coil is closed. As a result, there will be two fluxes, one generated by the current, this current, one due to the induced EMF in the second coil, which create a current flow. As a result, we produce a second flux, which is displaced from the first flux. But with this direction unit opened, there will be no second flux that interact with the original flux. As a result, won't move. This is another way of seeing the same direction relay is the one at the bottom of the sorry, at the top. So this is the directional relay. Can you see that? Are you okay? Okay, so this is the green one is the directional unit, and and this part is the overcurrent relay. So we attach these two together to make a directional overcurrent relay. So in the direction overcurrent relays, for directional relay, I have a voltage reference from a VT, okay, from the VT inputs as a reference, and the current will come from the CT, the CT somewhere here, which comes to these 2 points. So these CTs will come through this coil. The current flows here. Okay, and these are different taps for to choose the pickup setting. So this is the flow of the current, okay, from the CT. It will come here. Then go on which plug setting. Suppose I chose this plug setting, will come here. The current, then here. Okay, and returns back to CT. So it will go to the current coil of the direction unit and goes to the current coil of the overcurrent relay. Now, if this current higher than the pickup, okay, and the direction unit sees this is a forward, if it sees a forward, it will close these 2 contacts. I will change also the color. It will change. So it will change. Once this sees the fault, it will close this contacts, the directional relay. Once it sees a fault in the forward direction, it will close this contacts. Once these 2 contacts are closed, means the second coil, this coil, will be closed circuit. So if you can see, this is the ends of the coil of this coil. So once this coil is closed, okay, I have the overcurrent relay can operate now of the current, this current higher than pickup setting, and it will close these contacts. So the direction relay controls the operation, okay, of the overcurrent relays. Now how we set the reference point, which one is the reference point? For example, here we can use the angle between the voltage and the current as a criteria to decide if the fault is in the forward direction or in the backward direction. So suppose now, normal operating condition, I have a direction relay at bus A, and it has input current and a reference voltage. So this is our V reference. We call it V polarizing signal, and this is the operating current I operating. Okay. Now, based on these two currents, now during normal operating conditions, suppose I take my voltage at A as my reference. Okay, this is my reference now. For example, during normal operating conditions, suppose the power flow in this direction, the angle between the current I1, okay, and VA is very close to unity power factor. So this is almost, let's say, 0 at pre-fault, before fault occurs, at pre-fault condition. Once fault occurs, at F1, the current to flow is the fault current, I fault. Okay, and in this case, the fault current angle will be determined by the voltage, by the impedance from the source to the fault point. And this impedance, let's say at angle 80 degree, so the fault current will lag the voltage by an angle correspond to the fault impedance from the source to the fault point. So it will be lagging in this case. This is for all fault at F1. Now, when the fault at F2, the current in the CT will reverse into the other direction. So when the fault as
الو
comparing the angle of the reference voltage with the fault current. So how do we set, this is another way of representing the two units in series, direction relays, okay, with the overcurrent relay. And they are, both has to be operate for the trip coil of the circuit breaker to get a DC supply. This has to close both for DC supply, reach, energize the breaker trip coil, so this will trip. How do we set, now how do you choose this polarizing voltage? Which voltage? Is it VA or VAB or VB or VBC? So generally, this is the torque equation that represent whether the directional unit, directional relay will see the fault in the forward or backward. Okay. Once backward means the torque will be negative. If it's forward, torque will be positive. Okay. Now, the directional relay will have a current as input and a reference voltage. We call it V polarizing voltage. Okay. And now, suppose now our polarizing is our reference. Okay. Now, during fault, the current could be anywhere. It could be here, it could be here, it could be here, it could be, in this case, I showed it is here. This is the current at the present condition. So the current angle, the angle between the current and the polarizing voltage is theta here. This is the angle based on which I want to decide, is it this current forward or reverse? There is one line, we call it the maximum torque line. Is the line at which when the current falls in this line, dotted line, the relay will develop maximum torque. Okay, and we have a line perpendicular to the maximum line. We call it zero torque line, which is this one. And this is the line, when the current falls on this line, the relay will develop zero torque. And when a fault current is somewhere here, anywhere here, relay does not operate. Okay, it will restrain directional unit. So how do we develop this now? The torque equation will be a constant, depends on the number of turns, anything, core type, and magnitude of voltage, reference polarizing voltage, times the current inputs, times the cosine angle between the maximum torque line angle, which is alpha here, and the current angle. As you can see, when this is already fixed, we can fix it in the setting. The position of the maximum torque line, okay, is already fixed by one of the settings. Our setting. Yes.
دكتور انت بتشرح باي صفحه؟
عفوا.
رقم البيج اللي بتشرح فيه اي كم؟
بيج 14 حاليا.
واقفه ال 12 دكتور. بيج يعني احنا هلا حاليا يظهر لنا بيج 12.
ايه دكتور؟
انتم في 12 حاليا.
ايوه عشان هيك ضايعين دكتور، يعني نحاول.
اوكي انا حاليا في بيج 14.
دكتور صفحتين دكتور راحت.
خلاص. I will see another time, okay, to cover, I don't know. I will see what I have here.
دكتور.
نعم.
ممكن بس تدرج لنا تعملنا انسيرت يعني، او تدرج لنا النوت مع شرحك دكتور الاسهم هاي، لانه دكتور كان في ديلي قوي اليوم يعني بصراحه.
اوكي.
شكرا.
خلاص ان شاء الله. اوكي. I'll try to explain it in another way. اوكي. او اعيد لكم وقت ثاني، اخذ وقت ثاني بقول لكم this is the time. Okay, or I will try to record it and send it to you all synchronized. Okay. الحين تشوفون رقم 14؟
لا دكتور نشوفها 12.
الحين 12 عندكم.
ايه دكتور 12
قطع مره واحده من الساعه دكتور، ما ادري يعني مره واحده قطع.
انا ما ادري الحين قاعد يصير لي ريكورد او لا.
لا يصير ريكورد دكتور.
ريكوردد؟ اوكي.
بس ما في فايدة إذا اللي قاعد يصير له ريكوردينج هو اللي يطلع علينا كلنا.
يمكن ما يطلع نفس الشيء، خلينا نشوف بعدين الريكورد قد يكون سينكرونايز، وبالتالي ما احتاج اني اعيد الريكوردينج. اوكي. خلينا نشوف بعدين how the outcome will looks like recorded. hopefully انه مو نفس اللي قاعدين تشوفونه، انه delay. If it's same I will try to repeat it, don't worry. اوكي. الحين لا زال ما تشوفون رقم 14 سلايد 14 لانه هو اهم سلايد الحين.
لا دكتور ما
للحين اوكي. I will stop today here. اوكي. انا كان هدفي اليوم اخلص الدايركشن ريلي، بس it's useless if I continue and you are not following with me. All right. I will stop recording.